Go. Hey, so guys, this sounds weird because normally we do this just without even thinking about it. We are not going to start today by looking at the calendar. There's really nothing pressing coming up other than remember that today is the second and last opportunity for you to do remediation. So if you're hot in the middle of that, make sure that you're prepared for that. Watch the video, take notes, do the assignment, and join us today after school. Guys, understand that we're not going to wait. So if you're not here after 5 minutes into Flex, we're just going to roll without you. We're going to lock the door. You've got to be here on time. This has got to be your priority. So get here quickly. So guys, this is what we're up to today. We all survived Valentine's Day, which makes today the 15th. And the topic for today is on the board. If you're getting used to organizing your notebooks and doing stuff like that, guys, today we've got molecular names and formulas. I think I just figured out how I'm going to do this. So guys, as you're writing this down, some of those words should be especially familiar. Some of these words might be a little distant to you, but I think if we can pull them all together, you might get a sense of what we're up to. So guys, the idea then for me is this. Over the last couple days, we have learned to write the names, well actually formulas first, and then last time we learned to write the names, but not for molecules, for what? For salts. So guys, up until now, and given what we just graded on the board, you've demonstrated an ability to do this and this, but not with this. So we know how to write the names, we know how to write the formulas for salts. We've got all of these ideas about when we're writing formulas, as Kimball got us thinking. We look up the charges, we find the least common multiple. If we need more than one of a polyatomic, we put it in parentheses, all of that stuff. And then guys, we learned that when we're writing names, we name the positive ion, we name the negative ion, and then if the positive ion can have more than one charge, we need a Roman numeral. You remembering all of that stuff? Well guys, here's the deal. Today we're going to do exactly the same thing with molecules, but the rules are completely different. So guys, for the next 15 minutes, take everything that you learned about doing this with salts and forget all of it. There's no similarities whatsoever between naming and formulas for salts and namings and formulas for molecules. We're starting completely over. So guys, let's remind ourselves of this first. What atom pairings form molecules? Let's remind ourselves. What do we know about the metals? They're big and they're fat and they're weak and they give away electrons. What do we know about the nonmetals? Small and strong, and what do they do with electrons? Take them in. And so guys, when two nonmetals get together and they fight over electrons, nobody wins, nobody loses, they share. That's covalent bonding, and that forms molecules. So guys, here's the deal. When we're talking about molecules, we are talking about gatherings together of two nonmetals. And we drew Lewis dot structures and polarity arrows and all that other stuff. But guys, today we're going to learn to name those things. Do you understand where we're going? So let's talk about the rules. Ha, wouldn't you know it? My board freaked out. All right. So guys, it goes like this. You're going to take about half a page of notes today and you're done for the day. Like we're going to be done in about 10 minutes. This goes really fast. So guys, why? Why, Matthew? Why?
You gotta click off.
I know. I hate that though. All right. Here we go. So we're going to go boom, we're going to go boom, and we're going to go boom. All right. So guys, this is conversational. Don't write it down. But here's where we are right now. For the past couple days, we've been writing names and formulas for salts. And as I said, guys, you got to forget all of that, because now what we're going to do is no longer talk about these combinations of metal to nonmetal or metal to polyatomic. Today we're going to talk about how to name and write the formulas for the covalently bonded stuff, the molecules. Now guys, again, if you're not clear, this involves either two nonmetals or we got to include hydrogen. Guys, remember we talked about that before. For example, if you have H2O. We've drawn the Lewis dot structure for this. It looks like this, but you're like, wait a minute, hydrogen is a metal. Isn't that a salt? And you guys all comfortable with the idea that hydrogen is that freakishly strong metal that forms covalent bonds? Is that okay? All right. So guys, that then sets the stage. Today, we are going to look at groupings of nonmetals or hydrogen in a nonmetal because hydrogen's weird strong, and that forms covalent bonds, that forms molecules, and we're going to learn to name them and write their formulas. Yeah? All right. So guys, with that said, how do we do that? And the answer, if I can stop drawing lines, is this. Guys, these are the rules. This goes fast, and then we're done. So guys, these are the rules for writing, for working with molecules. It has nothing to do with Roman numerals. It has nothing to do with parentheses. Guys, all of that stuff is gone. Charges are gone. All of that is gone. It's all about prefixes. Everything changes, guys, and now we use prefixes. But here's the thing. Most of you, I think, already know about this because you know the name of the molecule I just wrote up on the screen. What is that? Carbon dioxide. What does the di mean? Those are prefixes, yeah? Because that's all there is to this. The only thing that you've got to figure out is this. Why don't we call this monocarbon dioxide? And there's a rule for that. But guys, that's all. It's really this easy. All you've got to do is look at this and go 1 carbon, 2 oxygens, di means 2. So this is carbon dioxide and you're done. That's really all there is to this. Of course, to get there, you need to know the prefixes. So let me give them to you now. These you want to write down. So guys, it goes like this. Mono is 1. Di is 2. But you knew that because you know carbon dioxide. Tri is 3. But you knew that because a triangle has 3 sides. Tetra is 4, but you knew that because we did the molecular structures unit and you learned that tetrahedral has 4 domains. Guys, 5 is penta. You probably knew that because of the pentagon or things like that. Hexa you probably know is 6, like a stop sign is a hexagon. If you know that hepta is 7, you're probably in the minority, but now you know. Oct is 8, but you knew that because we've got the octet rule. Non is 9, and it kind of sounds like 9. And then, guys, you all know that 10 is deca because you know that a decade has 10 years in it. So, guys, most of these you knew. Hepta might be weird. You may have to sort of commit them back to memory. But if you just spend the time to think about these, guys, you're going to find that these flow pretty easily. Now I just have to wait for you to write them all down. You guys all caught up? You okay? You guys are quiet today. You okay? Tired? Need a hug? Bring it in. All right. So guys, it goes then like this. There's only one rule that you need to know, and it goes like this. When there is only one of the first atom, you don't use mono. That's why CO2 is not monocarbon dioxide. If there's only one of the first atom, you do not use mono. And then guys, I think this is probably self-evident, but we'll include it anyway. On the second element, you drop the ending and add IDE. Because that's it, we're done. That's literally all that you're going to learn today. All we're going to do now is we're going to look at 5 examples. You're going to actually 6. We're going to look at 6 examples. I think you're going to find these surprisingly straightforward. We will look at an example that brings up this idea of when there's only one of the first atom, don't use mono. We'll look at 5, then we'll look at one more, then we're going to wrap up the day and you're going to get your homework done. You guys okay to move forward? Are we good? All right. So, guys, I would encourage you to write these down as we do them together. So, SF6. So if you need, you can certainly look up and remind yourself that 6 is hexa. But now, guys, the question is this. What are we going to name this thing? Well, we know that 6 fluorines will not be hexafluorine. It will be hexafluoride. But what do we do with the sulfur? Is it monosulfur or is it just sulfur? And the answer is don't use the mono because it's the first one. So, guys, this would be sulfur and then hexa. Do notice, guys, this is 2 words. Sulfur and then hexa and then FL. Which way does it go? UO? Yeah. Oh, UO? No, is that really? Sorry, I guess I am doubting you. It is. Because the other one's flower, right? Never mind. All right. It's not flowering. You are, and then IDE. Guys, that's it. You okay? That's literally what we're doing today. Please ask questions as we go, but if you look at this and go, that's not too bad, it's actually because it's not too bad. You guys okay? Yeah.
So why does the second always end?
It's just the rules that there's a group. They're called the International Union of Pure and Applied Chemistry. There's actually a governing body that makes up all the rules for chemistry, and they just decided that's the rule we're going to use. So we do. We're stuck. I know. But we do it with salts too, though, right? Table salt is sodium chloride. So universally, we add "ide" to the end of all salts or molecules. Go ahead, Bri. That's a brilliant question. So you guys, do you understand this? You'll never turn, and I don't know if this is exactly your question. You guys understand you'll never turn to this when we're doing this? Because these are all ions. These form salts. And so, guys, when we're talking about what we're talking about now, it's only molecules. And because it's only molecules, it's things like sulfur, which is a nonmetal. Sorry, I'm in your way, Matt. Sulfur, which is a nonmetal, and fluorine, which is a nonmetal. So it's only the molecules, which then means it's only the nonmetals. And then, of course, hydrogen, because that one's weird. Did that answer your question? That was a great question. You guys, can we do a couple more? Do this one with me then. Let me clean up my mess. Let me go here. Wow. We got to figure this out. There we go. Yeah, I guess. I don't know. All right, there you go, guys. Let's take a swing at this. So obviously we've got 2 nitrogens and we've got 1 oxygen. So what are we going to do with 2 nitrogens? Do we call it nitrogen or do we call it dinitrogen? It is dinitrogen. Guys, the only time we drop the prefix is if there's one of the first one. So this would be dinitrogen. But now, what about the oxygen? How many are there? 1. But do we use mono in this case? And the answer is yes, because the only time we drop it is on the first one. And so, guys, this would be dinitrogen monoxide. I guess some of you are going, wait a second. I thought that 1 was mono and the atom is oxide. So when I bring those together, why don't I call it monooxide rather than monoxide? And guys, the answer is you could do this either way. If you bring these together and you call it monooxide, that's fine. It flows better if you drop one of the O's and call it monoxide, but either one is actually acceptable, so don't get caught up in it. Do you understand the principle, though? You okay? All right. We're going to do one more. Oh, it's already on the screen. Guys, we're going to do this guy now. Nitrogen actually forms a lot of interesting compounds with oxygen. And this one also exists. It's NO2. Guys, take a swing at it. Why don't you do that one on your own? You guys good? All right, so is this nitrogen or is this mononitrogen? Kale, don't miss this. Nitrogen or mononitrogen? Just nitrogen, right? Because we don't put mono on the first one. And then, guys, 2 oxygens would be dioxide. So this would be nitrogen dioxide. Like carbon dioxide, only with nitrogen. We okay? Can I just not write it down? Is that all right? Okay, so now, guys, and I think some of you see this coming, what we've got to do now is go in the other direction. And frankly, this even, I would suggest, gets a little bit easier. Because now you're going to be given the names and you need to write down the formulas. Guys, I would propose to you that a good strategy for this is write down the abbreviations for the elements, then throw the numbers on there, and you're done. So it literally goes like this. We've got dichlorine. That would be Cl. Then we've got oxide, which is oxygen. And then, guys, if it's dichlorine, how many chlorines do we have? 2. And if it's oxide, how many oxygens do we have? And, guys, that's it. That's all you got to do. You starting to feel confident with this? Let's do one more. But yeah, it's really, if you're looking at this again, guys, and going, hey, that's not so bad, it's really not that bad. Why don't you do this one on your own just to make sure. Then, guys, we're going to go off script for a second, and we're going to do one more. And then, guys, you're going to have, as I said, time to work on your homework. So we've got nitrogen and oxygen again. You don't have to do it this way, but I actually like the strategy of writing down the elements first and then adding the subscripts. So we've got dinitrogen, which is obviously nitrogen, tetraoxide, which is obviously oxygen. So dinitrogen would be 2, tetra is, and you're out the door. Because that's it. You okay? You're good? Okay, so guys, the only place this gets a little trickier is if you have more than 2 atoms. Sulfur, fluorine, nitrogen, oxygen, chlorine, oxygen. What if you have more than 1? Well, or more than 2. And guys, if that's the case, we end up looking at things, really? Have I cussed yet?
You can hold it on there a little bit longer.
No, I'm just frustrated. We need to fix this. All right. So, guys, sorry for the weird transition there. My board is not my friend. Did you understand where we're headed with this now? We've looked at examples, sulfur, fluorine, nitrogen, oxygen, where there's only 2 atoms. What if there's more? So, guys, in your notes, for example, what if you have this? A Cu and an S and 4 O's. And guys, we understand that the 4 only applies to the oxygen. So do we use mono with the copper? No. So guys, we're just going to write this out, and we're going to go copper, and then we've got 1 sulfur. Do we put mono on that? We do. So this would be mono sulfur, and then, guys, we've got 4 oxygens, so that would be tetroxide or tetraoxide. Oh, TET, sorry, those are backwards. So that would be tetroxide, and this would be copper monosulfur tetroxide. Yes? No. This is completely wrong. Guys, completely wrong. This is not copper monosulfur tetroxide. This is copper 2 sulfate. This is not a molecule. This is a salt. And I'm glad that you're grabbing your yellow sheets. Because, guys, now that and please don't miss this transition, because this is where this gets hard. So, guys, here's the deal. Over the last 3 days, you have learned to write the names and formulas for salts. over the last 3 minutes, you've learned to write the names and formulas for molecules. And you just learned that the rules are completely different, y'all. Completely different. When you are naming salts, you need Roman numerals if it can have more than one charge. When you're writing formulas for salts, you need to know the charges and the least common multiple, and maybe you need parentheses. Guys, there's all those salt rules. But then there's all the molecule rules, and there aren't many, but it's all about prefixes. But guys, you should at least understand that these rules are radically different. We've got rules for salts, we've got rules for molecules, and you have to know when to use which rules. So guys, obviously I led you to failure, right? This is not copper monosulfur tetroxide. This is copper 2 sulfate. How do we know that this doesn't get prefixes? What is the fundamental difference between a salt and a molecule? And guys, if you're not sure, follow the laser. The question we're asking is, what is the fundamental difference between a salt and a molecule? So guys, we've got metals and we've got nonmetals. What atom pairing makes up molecules? 2 nonmetals, right? Nitrogen, oxygen, sulfur, fluorine. Guys, these atom pairings make up the molecules. What atom pairings make up the salts? A metal with a nonmetal, or a metal with a polyatomic. So guys, how do we avoid the pitfall that had us use prefixes to name this? Really simple, guys. Where's copper in the periodic table? Find it. Literally, if you need to, stick your finger on it, guys. Have that tactile experience of going, oh, shoot. Guys, copper is element number 29. Is it a metal or a nonmetal? It's a metal. If copper is a metal, this ain't a molecule. See, Bree, how that ties into exactly what you were asking earlier? I love that you asked that question. Guys, copper is a metal. And if copper is a metal, this ain't a molecule. This is a salt. And so, guys, that's the key to avoiding making this mistake, is the very first thing you're going to do when you're dealing with these is you're going to look at the first element and you're going to ask yourself this question. Is the first element a metal? What if the answer is yes? Is it a salt or molecule? Salt. And then we're Roman numerals, parentheses, least common multiples, all of that. Guys, what if the first element is a nonmetal? Then it's a molecule, and then we play the prefix game. So guys, let's pretend like we're starting over. So now it goes like this. Guys, do this with me. Have the experience of writing this down. CuSO4. And we need to write the name for CuSO4. So now that we understand the challenge, what's the very first thing we're going to do? We're going to look up copper in the periodic table. We find out that copper is a metal. And guys, at that moment, we know that we are in salt mode. So stop. Guys, what does salt mode look like? And the answer is, when we name a salt, the tricky bit is Roman numerals. So now we go back to the periodic table, and copper is element 29. Does it need a Roman numeral? How do you know? More than one charge. So guys, what we're going to do is this. We're going to split this in half. Guys, do this with me. Split that bugger in half. And now we need to know the charge of sulfate, SO4. So we look at our periodic table, and what's the charge of SO4? -2. Now guys, this. Is it -2 times 4? Go slow. Is it -2 times 4? No. SO4, that whole package. Guys, this entire thing has a charge of -2, and there's only one of them. What if there was more than one of them? It'd be in parentheses. So guys, there's only one SO4, so this is minus 2, so this is plus 2, and plus 2 is formed by 1 copper, so plus 2 divided by 1 is 2, and this would be copper 2 sulfate, which interestingly enough is this pretty stuff. We're actually going to use this in lab on Thursday. But guys, this is it. This is copper 2 sulfate. Pretty blue stuff. So guys, some of you right now, I think, are appropriately concerned. You're going, how the crap am I going to keep all this straight? So guys, let me offer some strategies. Then let me offer an aid. So guys, strategies go like this. Slow down and develop patterns and rhythms. And guys, the rhythm goes like this. The first thing that you always do is look at the first element. If it's a metal, you shift into salt mode. If it's a non-metal, you shift into molecule mode. If you're in molecule mode, you're thinking prefixes and life is pretty straightforward. If you're in salt mode, then you're thinking about Roman numerals. You're thinking about parentheses if you're writing formulas. You're thinking polyatomic ion chart. So, guys, the question then becomes, how do you keep all of this straight? I have an organizer for you. Guys, use this as an aid, but do not use it as a crutch. You won't have this on the test. Oh, for the love. All right. So guys, it goes like this. You have all the answers in front of you, but that doesn't mean you disconnect. You have the answers in front of you, so that means it takes the emphasis away from writing and it places the emphasis on thinking and learning. So here's what we're going to do. We are developing rhythms. So guys, what does this rhythm look like? First of all, this. If you choose not to develop this rhythm, do not be surprised when this blows up in your face. Because this isn't something that we do because we're just trying to waste time. It's something that chemists do because it's the way we think about these things. So the very first thing that you're going to do is look at the first atom in the compound. And what's the important division that we're looking at? What are we trying to identify? Is that first element a metal or a non-metal? And guys, that limits us then to a couple choices. And so it goes like this. So if that first atom is a metal, it's a salt. If that first atom is a non-metal, it's a molecule. See how we've now made that division? Then, guys, the next thing we need to figure out is, are we writing names or are we writing formulas? Now, if we are naming a salt, guys, the next thing we do is we check on the periodic table to see if that ion that can have more than one charge, like copper, could be +2 or +1. And when that was the case, we then worked it backwards, found the Roman numeral, then made sure the second element, if it was an element, added an IDE. If not, it's A to right, and then we write the formulas. Guys, in that box is a distilling of everything that we know about writing the names for salts. Now guys, what if it's a molecule? An example is CuSO4. What if it's a molecule? Well guys, if it's a molecule, we use prefixes. And we learned that the only tricky rule is if there's only one of the first atom, you don't put mono. Yeah? Now, what if we're trying to write formulas? So guys, if we're trying to write formulas for salts, remember the way this goes. We write down the abbreviations and the charges. Polyatomics end in adenite. The elements end in "ide," with the exceptions of cyanide, peroxide, and hydroxide. Then, guys, we find the least common multiple. Then we figure out how many of each of these we need. Then we write the formula. And if we need more than one of a polyatomic, we use parentheses. Now, if we're dealing with a molecule, then guys, those are the simple ones that we did a minute ago, where it's just write down the abbreviations of the elements, use the prefixes to give you numbers, and you're done. Guys, that's it. But here's the trick. The way to get good at these is by practicing. So this is the way this is going to roll. Guys, this homework assignment today is appropriately long. You're going to find that it's going to take some time, because here's the deal. Don't hurry. Spend the time. That's why we're giving you like 40 minutes right now to work on this. Guys, the only way to get good at this is practice. So grab the homework packet with me and turn your attention to assignment 3. Guys, assignment 3, page 1, these are all molecules. These are all molecules. Page 1, they're all molecules. The first 10, you're writing the names by using the prefixes. 11 through 20, you're writing the formulas by using those prefixes to indicate numbers. Then, guys, turn the page. This assignment then becomes 2 other pages. And, guys, if you read the title at the top of the second page, it says this: Mixed ionic and covalent naming, and then below that, mixed ionic and covalent formula writing, and then that repeats on the next page. So guys, on pages 2 and 3, that is where this becomes critical, because it's at that point that you got to be on your toes, because some of these are salts, some of these are molecules, and they don't play the same game. Do you get the idea? Okay, so guys, the remainder of the time is yours to work on this assignment. Should you need support, ask the person next to you, and then if you still need support, ask me. But guys, you understand, we've got to be hyper-focused right now, because the worst thing we could do is walk away from this before we practice, because then you're not going to remember when you try. Kale?
Will we ever see 3 non-metals?
No. Well, hold on. No. Oh, yes, no. I was thinking about CuSO4, and this is a metal and 2 non. You will never see 3 nonmetals. You won't see that until your sophomore year in college, when you take this class, which is organic chemistry. And then the first month of organic chemistry is learning what's called nomenclature, which is the process of naming those bigger molecules. You won't see that ever in high school, or even your freshman year in college. So, you guys okay? So guys, while you are working on this, let me stop recording. There's one more thing I want to mention to you.